Day grade 11s, welcome to my revision lesson with KHUMALO.M, the Geography Sangoma. Grade 11s, I hope if you have not subscribed to my channel, you can subscribe as we are going to be working together throughout these examinations. Grade 11s, what are we going to look at today? We are going to look at the revision of question 1 for paper 1 that you'll be writing on the 9th of November if you are in Tshwane South. But if you are in other sections of or other parts of Gauteng, you have specific dates per district. Now, let's take a look at first our question paper. How is it structured? How is paper 1 structured? Now, this is what I want you to understand. The paper 1 in grade 11, forgive me for that grade 10, but the structure for grade 11 and grade 10 is the same. Question 1 is the atmosphere of 60 marks. Question 2 is geomorphology, 60 marks, and question 3 is geographical skills and techniques for 30 marks. Now you can see in question 1 that there is 7 or 8 marks, 7 or 8 marks for question 1.2, 15 marks for question 1.3, 15 marks for question 1.4, 15 marks for question 1.5, and the same structure applies in question 2. And then question 3, we have map skills and calculation for 10 marks, and we've got map interpretation that are based on paper 1 topics out of how many marks? Out of 12 marks. And then we've got GIS, which is out of what? Out of 8 marks. That means the total for paper 1 will be 150 marks, and you're going to write for 3 hours. Yes, you have written for 3 hours last year when you were doing grade 10. So still this year we are going to write for 3 hours for 150 marks. Now, the topics that are in question 1 in grade 11 is the Earth's energy balance, the global air circulation, Africa's weather and climate, and the last topic is drought and desertification. Let's take a look at the first topic, the unequal heating of the atmosphere and the transfer of energy. You have understood during January that the earth is unequally heated, and now the earth will try to bring about its own energy balance. So the areas that are closer to the equator do not get hotter and hotter. Why are these areas? Remember in grade 10 we told you that the sun heats directly to the equator, so hence at the equator there is high insulation. But now what we are also saying now in grade 11 is that that area does not get hotter and hotter. The reason being we've got winds and ocean currents that act as a transportation of heat and energy across the earth, the planet Earth. Now, winds and the ocean currents, they transfer surplus energy from the equatorial areas into the poles. Therefore, a heat balance is maintained on the planet Earth. Now, the other thing that I want you to ask yourself as you are studying is the significance of the Earth axis and the revolution around the sun. Now, why is it important for us to have this Earth axis and the revolution, which is a movement of the Earth around the sun? Now, annual circulation. Now, remember that grade 11s that the Earth axis, it allows us only one part of the earth to be heated while the other part is experiencing night. So the other part will be day and the other part will be night. But now, when we talk about the revolution now, remember, it is when now this planet Earth, it revolves around the sun. It moves around the sun, which takes 360 and a quarter days for it to happen. But back to Earth axis, remember Earth axis, we'll talk about the rotation of the Earth. And now what is the rotation of the Earth? When the Earth spins on its axis, that takes what? 24 hours, and that gives us day and night. So revolution, it gives us season. And then now we are going to understand things like solstices and equinox that you have learned in term 1. We've got 21 March, the date there where the sun is direct over the equator, and this is autumn. It happens when it's autumn in the southern hemisphere while it's spring in the northern hemisphere. 21 June, the sun direct over the Tropic of Cancer. winter in southern hemisphere and summer in the northern hemisphere in June. Remember, grade 11s, that we always said that whatever happens in the southern hemisphere, it is opposite what is happening in the northern hemisphere. For example, right now we're experiencing spring, they are experiencing autumn in the northern hemisphere. So you must know the following season in each hemisphere, the position of the sun at each season, the length of day and night, and solstices and equinox, in order for you to be able to answer questions that are relating to this content. Then we go to the beginning of global air circulation. You have done global air circulation, where you've talked about what are high pressure, what are low pressure. So when you're studying, you ask yourself, what is a high pressure, what is a low pressure? And then you will get to understand that now these two are different. So the characteristics of a high pressure, remember, the air is descending or it's sinking around the high pressure, and then the air around the high pressure circulating an anti-clockwise motion in the southern hemisphere and clockwise in the northern hemisphere. While the low pressure system has air that is ascending, there is a clockwise motion in the southern hemisphere and an anti-clockwise motion in the northern hemisphere. Another thing that you have to understand and remember, grade 11s, is that the relationship between air temperature, air pressure, and wind. Now, hot air expands and rises. So the hot air will expand and it will rise. This leads to low pressure on the Earth's surface. Cold air is dense and heavy. So now, because when they are warmer temperatures, we will be experiencing our low pressure system, because now the relationship between temperature and pressure is inversely proportional. What does that mean? It means when temperature increases, pressure decreases. So once it becomes colder, it means that the temperature is decreasing, then we are going to experience high pressure systems. Then when it becomes warmer, that means the temperatures are increasing, therefore we are going to experience a low pressure system. Then the air sinks to the Earth's surface. Air, which is wind, moves from high pressure to low pressure. So this is the general movement of air. Now we'll get to understand, according to the global air circulation, why now we have this thing that we call wind, because wind is defined as moving air. And now the air, when it starts to move, what causes the air to start moving? It is what we call the pressure gradient force, which I'm going to talk about later in this session. And now the pressure gradient force, it causes the air to start moving. And now how will this air move? It will move from high pressure into a low pressure. It's very important, especially for next year, grade 12. Now, pressure gradient force, pressure gradient, Coriolis force, and geostrophic flow. Now, what is pressure gradient force? Is the force that causes air to start moving. Then we've got Coriolis force. Now, what is Coriolis force? We learned that Coriolis force is the force that deflects air to the left in the southern hemisphere and to the right in the northern hemisphere. So the Coriolis force deflects air to the left in the southern hemisphere and to the right in the northern hemisphere. You can keep on singing it, you can record yourself and listen to yourself while you are saying this, or you can play this video while you're doing dishes or whatsoever, to keep on remembering these things that I'm saying. Then we've got a geostrophic flow. Now when now these two forces are at equilibrium, then we get a geostrophic flow, which will result in geostrophic winds. The pressure gradient, let's start with the pressure gradient now first. Now I want you to understand, we are going to talk about isobars here. Now listen to my nice song about pressure gradient. Listen, the closer the isobars, the steeper the pressure gradient, the stronger the winds. You can say it with me. The closer the isobars, the steeper the pressure gradient, the stronger the wind. Then we come to this side. The further the isobars, the gentler the pressure gradient, the lighter the wind, or the gentler the wind, or the weaker the wind. So you must understand. Now, once you see on your synoptic map having isobars that are closer to each other, what are isobars? Isobars are lines joining places of equal atmospheric pressure. So when they are closer to each other, it means that there is a steep pressure gradient, and when they are further apart, it means that there is a gentle pressure gradient. And then it also tells us about the low pressure and high pressure. So it's very important for you to understand this grade 11 in terms of your exam for the. Now, Let's look at the Coriolis force. It is a force that causes all surface winds to bend or curve or deflect or deviate from its direct route. That means the wind changes its direction. Winds do not blow in a straight line from an area of high atmospheric pressure to an area of low atmospheric pressure. Now, this is how I always explain it to my learners. Now, this pressure gradient force is going to cause this air to start moving from high pressure to low pressure. Now, as this air is moving, the Coriolis force is going to change the direction or deflect the direction of what? Of wind. Now, a pure example or a real life example. Now, let's say you are coming out from your house, you are walking on the street, then you meet someone that you owe. You are going to just turn and change the direction. So that is what the Coriolis force does. It changes the direction of wind. So it's very important for you to understand the Coriolis force. Then we've got the geostrophic flow or a geostrophic wind. Now, it is an upper air wind that blows parallel to the isobars at right angles to the pressure gradient. So it blows, this type of wind, it blows parallel to the isobars. So you can see our isobars now, they are drawn from the north to south, and now these winds are moving what? Are blowing parallel to those isobars, and they are at right angle to the what? To the pressure gradient force. Do you see now, grade 12, what we are talking about? There is Coriolis force, there is pressure gradient force. So when you are asked to draw a geostrophic flow, you must know that it has to do with pressure gradient, it has to do with Coriolis force, it has to do with the movement of that parallel to the isobars. Then we look at our world pressure belts. You must remember world pressure belts, tricellular circulation, winds related to global air circulation. Now remember grade 12, when we start with the winds, let's start with the winds. The winds, how do we define winds, or how do we give names to the winds? The winds, they are named through the direction in which they are coming from. If the wind is blowing from the east, going to the western side is going to be the easterlies or the easterly winds, or yes, the easterlies. Now, if it's blowing from the west going to the east, it's going to be called the westerlies. Same applies to you. When you come from your house, your surname is Khumalo, for example, and then when I go to work, then I find that my principal is Mkhojo, so I cannot be Mkhojo when I get to the school. That is the same rule that is applying here. The name that this wind is coming from, the direction that this wind is coming from, it is going to be named using the direction in which it is coming from. So if it's coming from the west, there's our westerly winds. If it's coming from the east, those are easterly winds. That one you must know, and you must always remember it. Also, the polar cell, the Farrell cell, the tricellular model, you must know, and the characteristics there. You must also know the temperatures, where they are high and where they are low. So where we find higher temperatures, there will be low pressure. Where there is low temperatures, there will be high pressure. That is why we have our high pressure. Most of our high pressures, they are on the polar regions, because now the sun hits directly to the equator, and then remember, the earth is heated latitudinally and seasonally. Now the latitudinal effect is that one, that the sun rays or insolation will be high at the equator, and it will decrease as it moves in each latitude. Then we look at the air mass characteristic. What is an air mass? An air mass is a large body of air with similar temperature and humidity characteristics picked up from a region where it develops. So from the polar region, we get a cold air mass. From the equatorial region, we get a warm air mass. Now they are only air masses until they are set in motion. Once they start moving, then we call it wind. It's no longer air, but it's wind. What is this? The source of air masses: surfaces that are geographically relatively uniform, like oceans, ice fields, massive land areas, and deserts. That is where we get our air masses coming from. Then we come to the trade winds. We talk about the monsoon winds. Now the monsoon winds, these are seasonal winds characterized by a complete reversal of wind direction between summer and winter, which results in total different weather conditions, especially rainfall between summer and winter. Now you can see in summer, now these monsoon winds are blowing towards the land, but in winter these winds are blowing from the land to the ocean. Now, let us remind ourselves the reasons behind that. One, the air, when it starts moving, it moves from high pressure to low pressure. So now, in summer, we have on the land, the low pressure systems are dominating. Why? Because there are higher temperatures on the land and the sea is cold. So it will have cold high pressure systems on the ocean. Now, once these high pressures are on the ocean in winter, in summer, therefore air will be moving into the land. Then we call it onshore winds. But if it's moving from the land towards the ocean, is offshore winds. Now, when it's cold during winter, we've got a cold a high pressure cell over the land. Remember that high pressure cell is called the Kalahari high pressure cell. So now air will be moving from the land into the ocean. So we call that offshore winds. Now we've got what we also call the Foehn winds. The Foehn winds, remember the Foehn winds that you have learned in term 1? The Foehn wind is a name used for air that starts from the windward side of the mountain areas and descends on the leeward side of the mountain as dry hot wind. So now this air, it's a hot dry wind that blows down the leeward side. That is the simple definition that you can keep. Either than writing the one that I've written here, you can say the Foehn winds are the hot dry winds that blow down the escarpment on the what, or on the leeward side. Now, why are they hot? Because when they descend, or when they are descending there, they become heated at a dry adiabatic collapse rate. What does that mean when we say at a dry adiabatic collapse rate? It means that for every 100 meter, this wind will increase in 1 degree Celsius in terms of temperature. Then we look at the climatic regions that we have. We've got the equatorial there in dark green, the light green, the savanna, the semi-arid, the desert, the Mediterranean climate region, the high veld, the humid subtropical. Those are just for you to note that there are different regional climate, African regional climates. Now, the role of oceans in climate control in South Africa. This is very important for you as you're going to grade 12, grade 11s, that we must understand that on the east coast, we've got what? We've got the warm Mozambique current, and then in the west, we've got the cold Benguela. Please forgive me, this diagram is wrong, grade 12s, grade 11s. That is not a warm ocean current, but it is a cold ocean current. The Benguela, it's cold. Please forgive me, this diagram is wrong. Now, there at the foot of South Africa, we get the warm Agalaha. So it's warm, and cold. So most of the cold air will be coming from the west coast and the warm air from the east coast. The air above the warm ocean current is warmed by the water. The air above the cold ocean current, it is cooled by the water. Warm air can now hold more water vapor than cooler air. Therefore, the ocean currents have a great influence on climate because of their effect on temperature and humidity, which is moist. Now, there we come to another concept which we say El Niño and La Niña. I always say they are brothers. Now, during El Niño, warm water is pushed back east towards the west coast of America. Now, during El Nino, warm water is pushed back to the east, towards the west coast of America. Then El Nino means little boy or Christ child in Spanish because it occurs during December. Now, that is the reason why they call it Christ child, but they won't ask you why is it called Christ child. South American fishermen first noticed periods of unusual warm water in Pacific Ocean in the 1600s. El Nino is the cause of drought in Cape Town. So El Nino will give us what? Droughts. Let's see what La Nina is going to do. If El Nino is causing us drought, therefore La Nina must do it must create different weather phenomena. Now La Nina, it means little girl. The pattern is the opposite of El Nino. It's strengthening winds across the Pacific and it pushes warm surfaces water away from bringing up colder water below. La Nina conditions can last just as long as El Nino conditions, anyway from 9 to 12 months. La Nina could lead to increased rainfall, which is going to lead into what, grade 11s? Floods. So El Nino, drought. La Nina, floods. El Nino, drought. La Nina, floods. Always remember that. It's very important for your paper on the 9th of November. Then we go to drought and desertification. What is drought? We must know the areas that are at risk. We must know what is drought. That drought is defined as an extended period of below average rainfall. When an area receives below average rainfall, then we say it experiences drought. Then desertification. Now drought leads to desertification. We don't start with desertification, but we start with drought. It starts as a drought, and as a drought it continues, then it can lead to an area becoming a desert, which we call it a desertification process. So desertification is defined as a process of land degradation in mainly arid and semi-arid, subhumid and dry areas. Remember, South Africa is one of the countries that are regarded as semi-arid, which means it's partially dry. Then the causes of drought, we must know: excessive build-up of heat on the Earth's surface, meteorological changes like a reduction in the amount of water vapor available, a reduced cloud cover leading to great evaporation rates, less rainfall due to weather patterns changing, climate change, ocean and atmospheric weather cycles such as El Nino. They are the causes of drought. And how can drought affect us? The effects of drought and desertification. So the effects of drought and desertification, they are the same, but the causes of drought and desertification, they are more or less the same, but they are different. Some of them, they're different. Now the effects, before we get to the effect, let's look at the causes of desertification. It's climate related processes like global warming and climate change. Farming is done in an unsuitable land. Poor agricultural practice such as overgrazing, deforestation, soil erosion, lack of knowledge causes people to degrade land, and policies leading to unsustainable use of resources lead to desertification. Now, what are the impacts? How are they going to affect us now? The effects of drought and desertification is that there will be fewer crops, and when there are fewer crops, it means that there will be less food. You will be hungry and you will die. Okay, you're not going to die, but you will be hungry and you will suffer from malnutrition. And it will also lead to unemployment, because people who are working in farm will lose their jobs. People who are working in food productions will lose their jobs. Rural depopulation, people will tend to move from rural areas and come to cities where they can get food. Soil erosion, the wearing away of top fertile soil, will occur due to drought and desertification. Fire due to dry vegetation, and less exports, meaning that there will be less foreign currency. The management of droughts and desertification. What can we do? I told you, grade 11s, that this is a management subject. So we talk about the problems and we just don't leave the problems hanging. We talk about the possible solution or the management strategies of drought and desertification. We look at things like policy approaches that promote sustainable resource use, research to predict droughts, water restriction and recycling of water, construct dams. So that is what can be done to prevent drought and desertification, or to manage rather than to prevent. You must be able to answer the following questions in the exam. What is drought? The definition. What is desertification? What are the areas at risk? What are the effects of drought and desertification? And how drought and desertification can be managed. This is from me, KHUMALO.M. I hope you've enjoyed the lesson and you're going to ace that exam. The question papers, you'll get them from your teachers. They will get them from the group chat. They will send you across Gauteng. This is me, KHUMALO.M, the Geography Sangoma in Sonde South. Have a lovely day. Bye-bye.